Now coming to problems session. We estimate the fugacity of isobutylene as a gas at 553.15 Kelvin at 20 bar and at 553.15 Kelvin at 100 bar. Estimate the fugacity of isobutylene as a gas at 553.15 Kelvin at 20 bar, and also estimate the fugacity of isobutylene as a gas at 553.15 Kelvin at 100 bar. Here given data is Tc is the critical temperature at 417.9 Kelvin and Pc is the critical pressure, that is 40 bar, and omega is the eccentric factor 0.194. These values are taken from tables. Now coming to solution. Here our aim is calculation of fugacity. Initially we have to calculate the fugacity coefficient from ln phi is equals to Bp by RT. ln phi is equals to Bp by RT. Here Bp can be calculated from Bpc by RTC is equals to beta naught plus omega beta dash. Here beta naught and beta dash are the constants, and beta naught and beta dash are calculated from correlations. Here beta naught is the 0.083 minus 0.422 divided by TR power 1.6. Beta dash can be calculated from 0.139 minus 0.172 divided by TR power 4.2. After calculating the beta naught and beta dash, we can calculate the B value by using Bpc by RTC is equals to beta naught and omega beta dash. First of all, calculate beta naught. Here Tr is the T by Tc, that is given temperature divided by critical temperature. 553.15 Kelvin divided by 417.9, that is 1.323. After getting the value of Tr, we can calculate the beta naught, that is minus 0.1866. Then calculate beta dash, that is equals to 0.139 divided by 0.172 divided by 1.323 power 4.2. Beta dash value is the 0.0859. After getting the values of beta naught and beta dash, we can calculate the B value. Here R value is the 83.14 centimeter cube per bar. Here given pressure is in bars. That's why we are taking R value in bars. B value is minus 147.6. After getting the B value, then substitute in ln phi expression. That is ln phi is equals to Bp by RT. That is ln phi is equals to minus 147.6 minus 20 divided by 83.14 into 553.15 Kelvin. After simplification, we will get the value of phi is 0.93. After calculating fugacity coefficient, fugacity can be calculated from F is equals to P into phi. Fugacity is equals to pressure into fugacity coefficient. Here given pressure is 20 bars and calculated phi is 0.938. Therefore, F is equals to 18.76 bars. In this problem, our aim is pure species fugacity. In this problem, our aim is calculation of fugacity of pure species. That is calculation of F. F can be calculated from fugacity coefficient. The relationship between fugacity and fugacity coefficient is F is equals to pressure into phi. Initially, we have to calculate phi. From ln phi is equals to Bp by RT. Here, B is calculated from Bpc by RTC is equals to beta naught plus omega beta dash. Beta naught and beta dash are the constants. These two are calculated from correlations. After getting the values of beta naught and beta dash, we can calculate the B value. Then we can get the value of phi. After getting the value of phi, we can calculate the F value. That is 18.76 bars. Now coming to next problem. Here, determine the compressibility factor, fugacity and fugacity coefficient for N2 and CH4 in a nitrogen methane mixer at 200 Kelvin and 30 bar. If the mixer contains 40 mole percent N2. Here, determine the compressibility factor, fugacity and fugacity coefficient for N2 and CH4 in a nitrogen methane mixer at 200 Kelvin and 30 bar. If the mixer contains 40 mole percent nitrogen. Experimental virial coefficient data is B11 is equals to minus 35.2, B22 is equals to minus 105, B12 is equals to minus 59.8 centimeter cube per mole. This is the given data. Now coming to solution. Here our aim is calculation of fugacity coefficient in mixer. That is calculation of fugacity coefficient in mixer or binary mixer. Here we have to calculate phi 1 cap and phi 2 cap. That is fugacity coefficient in solution by using the formulas. Ln phi 1 cap is equals to P by RT into B11 plus Y2 square delta 12. Ln phi 2 cap is equals to P by RT B22 plus Y1 square delta 12. Initially, we have to calculate the delta 12 value by using 2B12 minus B22 minus B11. B12, B22, B11 are the virial experimental coefficients. That coefficients are given in our problem. Here we have to substitute the B values. 2 into minus 59.8 minus 105 minus 35.2. After simplification, we can get the value of delta 12. That is 20.6 centimeter cube per mole. After getting the value of delta 12, we will calculate the phi 1 cap. That is ln phi 1 cap is equals to 30 divided by 83.14 into 200 into minus 35.2 plus 20.6 into 0.4 whole square. 0.4 whole square is the Y2 square. That is the mole percentage of methane. And 83.14 is the R value. That is equals to minus 0.0575. Phi 1 cap value is 0.953. Phi 1 cap value is 0.953. After getting the value of phi 1 cap, we will calculate the phi 2 cap by using the formula ln phi 2 cap is equals to P by RT into B22 plus Y1 square delta 12. That is 30 divided by 83.14 into 200 into minus 105 plus 20.6 into 0.6 whole square. Here 0.6 whole square is the mole percentage of species 1. 83.14 is the R. After simplifying, ln phi2 cap is equals to minus 0.176. Then we will get the value of phi2 cap, that is 0.8385. After getting the fugacity coefficients, we can calculate the F1 cap and F2 cap, that is fugacities of species 1 and species 2. By using the formulas, phi1 cap is equals to F1 cap by Y1P and phi2 cap is equals to F2 cap by Y2P. Therefore, phi1 cap is equals to F1 cap by Y1P. Here, phi1 cap is the 0.953, that is equals to F1 cap by mole fraction of species 1 and given pressure. Therefore, F1 cap is equals to 11.436 bars. Then we have to calculate the F2 cap. Calculated phi2 cap is the 0.8385. That is equals to F2 cap by 0.6 into 30. Here Y2 is the moles of species 2. Therefore, F2 cap is equals to 15.093. After calculating fugacity, we will calculate the compressibility factor. For compressibility factor, Z is equals to 1 plus Bp by R. Compressibility factor formula is 1 plus Bp by R. Here, B is calculated from Y1B11 plus Y2B22 plus Y1Y2 delta 1. Already given Y1, Y2 values are Y1 is 0.4, Y2 is 0.6. B11, B22 values are given in our problem. Delta 1, 2 already calculated in this problem. Then substitute all the values in this expression. We will get the value of B. After getting the value of B, substitute in compressibility factor expression. That is Z is equals to 1 plus Bp by R is equals to 1 plus minus 72.136 into 30 divided by 83.14 into 200. After simplification, Z value is 0.869. In this problem, our aim is calculation of compressibility factor, fugacity and fugacity coefficients for a mixture nitrogen and methane. Here, nitrogen mole percentage 40 mole percent, that is 0.4. Remaining is methane, that is 1 minus 0.4 is 0.6. Moles of CH4 is 0.6. Here, experimental virial coefficient data is already given in our problem. Initially, we have to calculate the fugacity coefficients by using the formulas ln phi1 cap and ln phi2 cap. ln phi1 cap is equals to P by RT into B11 plus Y2 square delta 1. Similarly, ln phi2 cap is equals to P by RT into B22 plus Y1 square delta 1. Delta 12 is calculated from 2B12 minus BT2 minus B11. After getting the value of delta 12, we can calculate the phi1 cap and phi2 cap. After getting the values of phi1 cap and phi2 cap, we will calculate the F1 cap and F2 cap by using the formulas phi1 cap is equals to F1 cap by Y1P. Similarly, phi2 cap is equals to F2 cap by Y2P. After getting the values of fugacities, we can calculate the compressibility factor. From Z is equals to 1 plus Vp by RT. Here B is equals to Y1 B11 plus Y2 B22 plus Y1 Y2 delta 1. Here Y1 Y2 are the mole fractions of species 1 and species. After simplifying, Z value is 0.869. This is the procedure for calculating compressibility factor, fugacity and fugacity coefficient.